Alright guys, today's goal, 10.1 limits in motion. The learner will understand average velocity, instantaneous velocity, limits revisited, the connection to tangent lines, and the derivative. And why? The derivative allows us to analyze rates of change, which are fundamental to understanding physics, economics, engineering, and even history. So let's take a look at some definitions. Average velocity is the change in position divided by the change in time, often symboled in this by change in position over change in time. That delta symbol means change in. Okay, that's something you'll see in sciences, chemistry, physics very often. When we write the limit as x approaches a of f of x equals L, we mean that f of x gets arbitrarily close to L as x gets arbitrarily close to but not equal to a. Use the limits to find the slope of the tangent line of the graph. S equals t to the third at the point 1, 1. Okay, so what we want to do here is we want to say the limit as t approaches 1 of the change in s over the change in t, which the way we do that is f of t minus f of a divided by t minus a. So what that is the limit as t approaches 1 of t to the third minus 1 over t minus 1. Okay, so the way I got this t to the third and the 1, see it said f of t, so that means plug in t for this function and you get t to the third. Plug in 1 to this function, you get 1 to the third, which is 1. Okay. Now remember, this factors into t minus 1, t squared plus t plus 1 divided by t minus 1. So the limit as t approaches 1 is t squared plus t plus 1. Well, as it's getting really close to 1 there, or to 1, that means, let's look at this. 1 squared plus 1 plus 1, well, that's 3. So there's your limit, 3. Okay? So anytime they're asking us, use limits to find the slope of the tangent line of the graph, s equals t to the third at a point, we use this function. Okay? Let's look at some more definitions now. If y equals f of x, then the average rate of change of y with respect to x on an interval a to b is the change in y divided by the change in x, which is f of b minus f of a over b minus a. Geometrically, this is the slope of the secant line through a comma f of a and b comma f of b. So there's average rate of change. Now the derivative of a function f at x equals a is denoted by f prime of a, and red f prime of a. Is f prime of a equal to the limit as x approaches a, which is f of x minus f of a divided by x minus a, which is similar to what we just did, provided the limit exists. So the limit has to exist. Geometrically, this is the slope of the tangent line through a comma f of a. The derivative of a function f at x equals a is denoted by f prime of a, and red f prime of a is the limit as h approaches 0 of f of a plus h minus f of a divided by h, provided the limit exists. Okay, so here's two different ways to do derivatives of functions. Let's look at some more examples. Alright, it says find the derivative at the point f prime of 3 if f of x equals 2x plus 4. So look up here. So the first thing you got to do is see how it says a plus h. So that means find f of 3 plus h. So plug that in for the x, and you get 2h minus 10. And then f of a, so the function of 3 is 10. So now we need to set this up. So you say the limit as h approaches 0 of 2h minus 10, 2h plus 10 minus 10 divided by h as h gets closer to 0. Well, that's the limit as h approaches 0 of 2h over h, which cancels. So the limit is 2. Now, if you also look at the other one, that was as x approaches a, if you look back on the other page of the notes, it's the limit as x approaches a. If we look at that, watch. So what we would have is let me do this. The limit as x approaches 3 of f of x minus f of 3, which is 10, divided by x minus a. Well, that's the limit as x approaches 3 of 2x minus 6 over x minus 3, which is the limit as x approaches 3. Factor out the 2, you get x minus 3 over x minus 3. So those cancel, so the limit is 2. So see, both of those definitions that we learned on the previous page work. Let's look at another example. If y equals f of x, then the derivative of a function whose f with respect to x at x equals a. So we're using this again. So it says find the derivative of the function of f prime of x. Okay? So you go f of x plus h equals 2 times x plus h squared, which equals 2x squared plus 4xh plus 2h squared. And then we need to find, and then we know f of x equals 2x squared. So now we set it up. We have the limit as h approaches 0 of 2x squared plus 4xh plus 2h squared divided by, minus, so there's f of x plus h minus f of x divided by h. And then that would equal the limit as h approaches 0 of 4xh plus 2h squared over h. We'll factor out the h. The limit as h approaches 0 of h times 4x plus 2h over h. And that equals 4x plus 2h, but h is approaching 0, so that's gone. So the limit 4x, which is also the derivative of this function. Okay? Alright guys, I'll see you guys tomorrow.